Welcome to our series on cyclic geometry. In this lesson, we are going to determine the relationship between the exterior angle of a cyclic quadrilateral together with the interior. How do these two relate, if there is any relationship between them? Now let's try to view what is this exterior angle of a cyclic quadrilateral. Let's first draw our cyclic here, and then let's draw our quadrilateral inside that cyclic, and then we are going to call this quadrilateral a cyclic quadrilateral, like that. Then what is this exterior angle? If you can extend one of these sides like that, there is an angle formed outside the quadrilateral. This angle here. Now that's the exterior angle we are referring to. Another one can be there. Let's extend this side like that. Then this is the exterior angle. Another one can be there, just like that. That's the exterior angle of the cyclic quadrilateral. Then our topic of today, we want to explore the relationship between this angle together with the interior angles, if any exist. Now let's just assume you are given the value of this angle here as 70 degrees. Can you be able to find the value of the exterior angle given the interior angle there? There is a theorem that we've just covered which talks something about opposite angles of a cyclic quadrilateral. It says the opposite angles of a cyclic quadrilateral at up to 180 degrees. So if we put x here, what does this tell us? If we put x, if you have your x there, we know that opposite angles with 70 and x, they should give us 180 degrees. Then if you subtract 70 degrees from both sides, x is going to be 180 degrees minus 70, which in turn tells you that the value of x is nothing but 110 degrees. Now from there, what is happening here? These are angles on a straight line. Those are angles on a straight line, which means that if this is 110, then add something here to get to this to get 180, and that should be 70 degrees. Now let's look at this thing now. This angle is equals to that. What are those angles? Now this is an exterior angle and this is the interior opposite angle. Now there is a relationship between the exterior angle together with the interior opposite angle. Now let's try to generalize this theorem. But before we generalize it, let's just try to go to GeoGebra to view this. Let's go straight to GeoGebra and then draw a circle. And then in the circle, let's draw our cyclic quadrilateral. Now that's a cyclic quadrilateral. Now, from there, let's try to extend one of these sides. Let's try to extend one of its sides, maybe this one. And then we have something like that. Nice one. Now let's do the proper measurements here. This is the interior. Now this is the interior angle at B. It's 100 degrees. How about the exterior opposite angle there? 100 degrees. So this is actually not a coincidence. It's actually not a coincidence that these two angles are equal. As you can see, they will always be equal. They are always equal, these ones. So the exterior angle of a cyclic quadrilateral is equals to the interior opposite angle in a cyclic quadrilateral. Now let's try to use some algebra to prove this one. Let's try to use some algebra to prove it. For every claim you make, we must be able to prove it. Now again, we are going to draw our circle here and then draw the quadrilateral. We want to show that these two angles are actually equal. This one together with that. This is the interior opposite angle. This is the exterior angle. We want to show that they are equal. Let's just put a general value here, maybe x. And then we want to find the value there. Now let's do the math here. We have our theories. One theory is telling us that once they become opposite, they are going to add up to 180 degrees. What is this angle? So this angle is 180 take away x. So this is 180 take away x. 180 take away x. So that if you add these two, you are going to get 180. Right, x plus 180 plus x plus 180 minus x is equals to, this is actually equals to this x going to cancel together with that. And then that thing there is actually going to give you 180 degrees. So then from there, let's find this angle on the other side. Maybe let's call it y. So your 180 minus x plus y should give us 180 degrees. We want to find the value of y. We need to first subtracting 180 from both sides. Then this guy will cancel that. Same applies to this side. This guy is cancelling that. Then you are having minus x plus y is equals to 0. Then from there, let's add x on both sides of the equation. Add x, add x. Then from there, this and this, they cancel out. Then we are left with y is equals to x, which means that this angle there is actually x. So we've came up with our theory, which says that the exterior angle we are referring to this one here. The exterior angle we are referring to this angle there. That's the exterior. What's going on here? That's the exterior angle. It's that one there. So the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So the interior opposite angle we are referring to this one here. So basically that's the theorem. Let's go straight to examples. Now here is our example number 1. We are told here that in a cyclic quadrilateral ABCD, CD is extended to A. Then if angle B is 72, find angle CDE. Now let's try to draw this thing so that we can be able to see what's going on here. We have something like this. I won't draw an accurate drawing. I'll just do a random sketch here. So basically this is what we have, and then this should be D, so that it's being extended to E. And then this is A, B, C, then D, like that. Now what's happening here? If angle B is 72, this angle here is 72, find C, D, E. This is the angle you are required to find, this one here. And then that's what you are given. Now this is the opposite angles of the cyclic quadrilaterals. These ones, they are opposite. And then this one here is the exterior opposite. So we're expecting this one. This angle is actually 72 degrees. Let's just write the solution. So angle CD is equals to 72 degrees. Now what's the reason for that? Exterior angle is equals to the interior opposite angle. Just like that, we are done. Rather than going through the stuff saying this one plus this should give us 180 and this should be 108, and then saying 180 minus 10, then you get 72. You just use the theorem. Exterior angle is equal to the interior opposite angle. As simple as that. Next example. Example number 2. In a cyclic quadrilateral MNOPQ, the exterior angle at O, that's angle NOQ, is 63 degrees. 63 degrees. You've got 63 here. And then you are required to find the exterior angle at M. Let's find the exterior angle at M. So basically, it's either you are going to extend PM. If you decide to extend PM, you are going to have something like this, and this will be the angle you will be looking for. And then if you decide to extend NM, this will be the angle you are looking for. And basically these two angles are just equal. So let's first find the angle here, which is the interior opposite angle. So in doing that, our M is equals to 63 degrees. The reason, the exterior angle is equals to the interior opposite angle. Then from there, this angle here we are actually looking for, let's call it X. If you like, it could be this one, either way. So now you have your 63 here. So to find X, 63 plus X should give you 180. Those are angles on a straight line. Then your X is equals to 180 minus 63, which tells you that your X is equals to 117 degrees. Next example. Now in the cyclic quadrilateral RS, PQRS, RS is extended to T. So if you extend RS to T, either go this way or that way. Now let's look at the equation. Then you are told that RPS is 42. We're actually doing nothing with that angle there. I guess it's just a distractor. RPS, they are referring to this angle here. They are telling you that this is 42, and then the angle at Q is actually 98 degrees. Now let's check. Find the exterior angle at S. So we are looking at the exterior. We are looking for this angle here. And this is the exterior angle, and then it should be equals to the interior opposite angle there. So it's got nothing to do with the 42. There is just a redundant. So your angle, exterior angle at S, which is TSP, is equals to 98. The reason, exterior angle of exterior angle is equals to the interior opposite angle. Next question, which is example 4. In a cyclic quadrilateral, W, X, Y, Z, YZ, where is YZ? It's this one. Is extended to K. I've extended the wrong way here. It's YZ. So from here, I'm going down there. Then there is our K there. Now what was the equation? Then KZY, K now KZY is a straight line, which means I've done an error here. So K like this. KZY, this angle here. This is X plus 10. And then the angle at X, this one, 2X plus 2X minus 20. And then these two angles, this is the interior opposite angle. This is the interior opposite angle. This is your exterior. So these two are actually equal. So solving for X, we are just going to equate those two angles. 2X minus 20 is equals to X plus 10. First things first, let's add 20 on both sides of the equation. And then this one, it's going to be cancelled out. Then you have your 2x is equals to x. 10 plus 20, that's a plus 30. Then subtract x from both sides. And then what happens? These guys are going to go away. 2 minus 1, that's 1. Then you are left with x is equals to 30 degrees. So that's the value of x. So we are done with this theorem, which says that the exterior angle of a cyclic quad is equal to the interior opposite angle. Thank you for staying tuned.